ratios are just the reciprocals of the primary trig ratios. And a reciprocal is just defined as 1 divided by each of the primary trig ratios. It's just the flip of each of them. Before I explain them, it'll help if I draw a right angle triangle with a reference angle theta. A quick reminder of the primary trig ratios, sine, cosine, and tangent. They take an angle as an input, and what they output is a ratio of sides in the triangle. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tan of theta equals opposite over adjacent. And the acronym SOHCAHTOA can help you remember those ratios. The reciprocal trig ratios are called cosecant, secant, and cotangent. Now, they each have short forms. Cosecant, the short form of cosecant is CSC. The short form of secant is SEC. And the short form of cotangent is COT. Now, each of these trig functions, cosecant, secant, and cotangent, are just equal to the reciprocal, so 1 over its corresponding primary trig ratio. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now let's look more closely at what cosecant of an angle is equal to. Cosecant of an angle will give, once again, a ratio of sides, but it gives the reciprocal ratio of what sine of that same angle would give you. Sine of an angle is opposite over hypotenuse. Well, cosecant, because it's the reciprocal of sine, the ratio for cosecant of an angle is going to be, instead of opposite over hypotenuse, it's going to be hypotenuse divided by opposite. It's just the flip of the ratio. It's 1 divided by sine of theta. That just means the reciprocal or the flip of it. And if cosine of theta is adjacent over hypotenuse, secant of that same angle is equal to the reciprocal 1 over cosine of that angle. So you would get hypotenuse over adjacent. And if tan of theta is opposite over adjacent, cotangent, being the reciprocal of tan, is going to give you adjacent over opposite. Before we do any questions with this, I'm going to remind you of a couple tools you're going to need to remember. You need to know your isosceles special triangle with angles of 45, 45, 90, and side lengths of 1, 1, and root 2. You also need to know this half equilateral special triangle. The angles are 60 and 30, and the side lengths are 2, 1, and root 3. The other tool you might want to know how to use is the unit circle. Let me quickly draw that for your reference. So as a reminder, if we know the xy coordinate of where this terminal arm intersects the unit circle, the x coordinate tells us the cosine ratio of the angle, and the y coordinate tells the sine ratio of the angle. So using these tools, let's see if we can find the value of all 6 trig ratios for each of those 5 angles. Example 1 says, complete the following chart and give exact values for each ratio. Let's actually start by filling out the row for the 30-degree reference angle. Let's start by getting the sine ratio for 30 degrees. I'll look at my special triangle that has a 30-degree angle, and sine is opposite over hypotenuse. So sine of 30 degrees, I know, is 1 over 2. Cosecant is the reciprocal of the sine ratio for the same angle. So if I want cosecant of 30 degrees, I know it's equal to 1 over what I got for the sine ratio of 30 degrees. So it's 1 over a half. Doing 1 divided by a fraction just flips it. So instead of 1 over 2, it becomes 2 over 1, which is just 2. Let's now do cosine for 30 degrees. Cosine for 30 degrees, cosine of 30 is adjacent over hypotenuse, which is root 3 over 2. And secant is just the reciprocal of the cosine ratio. So secant of 30 degrees would just be the reciprocal or the flip of root 3 over 2, which is 2 over root 3. And of course, that could be rationalized. If we multiplied top and bottom of that by root 3, we would have 2 root 3 over 3. And now let's do tan of 30 degrees. So from the special triangle, tan of 30 means opposite over adjacent. That's 1 over root 3. If we rationalize that denominator by multiplying top and bottom by root 3, I get root 3 over 3. Now, if I want the cotangent ratio for 30 degrees, remember cotangent is just the reciprocal of the tan ratio. So to find cotangent of 30, I just have to flip the ratio I got for tan of 30 degrees. So 1 over root 3, flip it, it becomes root 3 over 1, which I could just write as root 3. So hopefully you see how we were able to get those values. I know you're probably good at getting the primary trig ratios, sine, cosine, tangent, for these special angles. So I'm just going to give you those, and then we'll practice writing the reciprocal trig ratios. All right, now that I've given you the primary ratios for 45 and 60, let's write the reciprocal ratios. So cosecant of 45 is equal to the reciprocal of the sine ratio of 45. So I have to flip 1 over root 2, and it becomes root 2 over 1, which is just root 2. The same thing happens for secant of 45, and then cotangent of 45. I do the reciprocal of the tan ratio for 45, so I do 1 over 1, which is 1. Cosecant of 60, I do 1 over the sine ratio for 60, which flips it, and it becomes 2 over root 3. Secant for 60, I do 1 over the cosine of 60 ratio, so 1 over a half, which becomes 2. And then lastly, cotangent of 60, I do the reciprocal of the tan 60 ratio, so I do 1 over root 3, which when rationalized becomes root 3 over 3. In our table, we have 2 more angles to find the ratios for, 0 and 90 degrees. I left those for last because when we want ratios for an angle that lands exactly on the x or y-axis, we want to use this tool, the unit circle, to help us find the trig ratios. When I find the sine ratio for an angle, that's equal to the y-coordinate of where the terminal arm intersects the unit circle. Cosine is equal to the x-coordinate, and tan is equal to sine over cos. It's equal to the y-coordinate divided by the x-coordinate of where you intersect the unit circle. So let me write down those values for 0 degrees. Right? If we rotate 0 degrees, the terminal arm intersects the unit circle at that point right there, which is the point 1, 0. The y-coordinate is 0, so sine of 0 is 0. The x-coordinate is 1, so cos of 0 is 1. And tan is equal to sine divided by cos, the y divided by the x, so 0 divided by 1 is 0. Now here's where it gets a little bit tricky. Cosecant of 0 degrees is 1 over sine of 0 degrees, so it's 1 over 0. 1 divided by 0 is undefined. So that means that cotangent is also going to be undefined for a 0 degree reference angle. And cotangent of 0 degrees is the reciprocal of tan of 0 degrees, so it's the reciprocal of 0. 1 over 0, undefined. Secant of 0 degrees would be the reciprocal of the cosine ratio for 0 degrees, so it would be 1 over 1, which is still just 1. And following that same logic, but for the point we would intersect the unit circle if we rotated 90, the point 0, 1, I could fill out these ratios for a 90 degree reference angle. And I'll do those quickly for you. And now let's move on and do a couple other types of examples that may include these reciprocal trig functions. Example 2 says the point negative 912 lies on the terminal arm of an angle in standard position. Determine exact expressions for the 6 trig ratios for that angle. So negative 912 is approximately right there. It's in quadrant 2 for sure, and it's on this terminal arm. What I'm going to do is I'm going to connect down to the x-axis from that point to create a right triangle that I can use as a reference to find my 6 trig ratios. Now, the angle theta that would take you to that terminal arm that has the point negative 912 on it, we could represent with that line there. There's angle theta. I can use the reference angle, which is the angle between the terminal arm and the closest x-axis. I call that beta. I can use that and the cast rule, which tells me in this quadrant only sine is positive, to help me write the 6 trig ratios. Before I start trying to get the ratios, I should also label some side lengths of this triangle. To get to this point, I would have to go 9 units that way and then 12 units that way, so I'll label those side lengths 9 and 12. And then if you used Pythagorean theorem, you could find out that the hypotenuse is 15. Now that I have all the side lengths of that triangle labeled, I should be able to write the sine, cos, tan, and cosecant, secant, cotangent ratios for this angle theta with the help of the reference angle beta and the cast rule. So I could say that sine of theta is equal to, well, I can use the reference angle beta in the triangle and I can keep the ratio positive because in this quadrant sine is positive. So I can say it's equal to sine of beta. And don't forget what SOHCAHTOA tells us, Sine is opposite over hypotenuse. So from the reference angle, I'll do opposite over hypotenuse, which is 12 over 15, which reduces 3 goes into both of those numbers 4 times and 5 times respectively. If I want cosine of the principal angle theta, I can use the reference angle as long as I remember that in this quadrant, cosine has to be negative. So it's equal to negative cosine of the reference angle. And cosine is adjacent over hypotenuse, so from the reference angle, do adjacent over hypotenuse. And remember to make the ratio negative, it becomes negative 9 over 15. And that reduces, 3 goes into both of those numbers, it reduces to negative 3 over 5. Tan of theta is equal to negative tan of the reference angle. And remember, tan is opposite over adjacent, so tan of beta would be negative 12 over 9. And once again, that reduces to negative 4/3. So there are the 3 primary trig ratios. The question wants all 6 ratios, so we now need the reciprocal ratios. Let me move this Pythagorean theorem note out of the way, and let's get the 3 reciprocal trig ratios. Well, the reciprocal of sine is cosecant, so cosecant of theta is equal to 1 over sine of theta. So it's equal to 1 over the sine ratio, which just flips it. 1 over 4 over 5 is just equal to 5 over 4. The reciprocal of cosine is secant. So secant of theta is equal to 1 over cosine of theta. So it's equal to 1 over negative 3 over 5. That just flips it. That makes it negative 5 over 3. Right? The sign doesn't change, just the fraction flips. And the reciprocal of the tan ratio is the cotangent ratio. So cotangent of theta would equal the reciprocal of the tan ratio. So it would be negative 3 over 4. There you go. There's all 6 trig ratios for the angle theta that takes you to that terminal arm, which has that point on it. Let's now solve a couple trig equations that involve reciprocal trig functions. In example 3, it says to solve the equations for theta, but only find the answer for theta that's between 0 and 90, this question says. So that means only the answer that's in quadrant number 1. So in this quadrant for both of these questions. Anytime your equation has a reciprocal trig function, we can switch it to the primary trig function. So instead of cosecant of theta equals 8, I can change it. I know the reciprocal of cosecant is sine, so I can change it to sine of theta. Well, if the cosecant ratio is 8, I know the sine ratio would be the reciprocal of that, which means 1 over that. So it would be 1 over 8. And now I can use my calculator to figure out what angle has that ratio of sides. The angle would be equal to the inverse sine function of 1 over 8. The inverse sine function takes an input of a ratio and it'll output an angle. In this case, the angle is about 7.18 degrees. So that's in quadrant 1. It's about right here. Let's try part B, where it says secant of some angle equals 5 over 2. Well, if we're trying to solve for that angle that has that secant ratio, I know if the secant ratio is 5 over 2, the cosine ratio, well, cosine is the reciprocal of secant, so the cosine ratio would be the flip of 5 over 2. It would be 2 over 5. And then we can find the angle that has that ratio by doing inverse cosine of 2 over 5. And that gives me about 66.42 degrees, which once again is in quadrant number 1. Let's try example 4, where we're going to have to find more answers. It says solve the following equation for theta, but find all answers for theta that are between 0 and 360. So we have cosecant of theta plus 2 equals 0. And our goal is to figure out what angle or angles makes this equation true. We'll start by isolating cosecant of theta. By moving the 2 to the other side, it becomes a negative 2. And if cosecant of the angle is negative 2, well, cosecant is the reciprocal of sine, so I know sine of the same angle would equal the reciprocal of negative 2, which means negative 1 over 2. Now I know there are going to be 2 angles between 0 and 360 that have this sine ratio. And based on the cast rule, I know the angles are going to bring you to a terminal arm that are in the 2 quadrants where sine is negative, which would be in quadrant 3 and 4, so I'll draw a terminal arm in both of those quadrants. And the relationship between these terminal arms is they have the same reference angle. So I can label the reference angle beta in both of those quadrants because I know they're going to be equal to each other. That's why they're going to have the same sine ratio of negative 1/2. Having that same reference angle, if I were to draw the unit circle, I would see that that would make both of those terminal arms intersect that unit circle at the same y coordinate, which is why it would have the same sine ratio. But what is that reference angle? Well, what's nice about this ratio of 1/2 is we can make that ratio from the special triangle. I'm looking for an angle that has a sine ratio of -1/2. Well, I know sine of 30, sine is opposite over hypotenuse, sine of 30 is +1/2. So what I can do is I can place that 30-degree angle as the reference angle in the two quadrants that make the sine ratio negative. So I can place the 30-degree reference angle in those two quadrants, and now calculate the principal angle, which is the angle that goes from the positive x-axis counterclockwise to each of these terminal arms, and then I have both of my answers for theta. Theta 1 goes past 180 by 30 degrees. So 180 plus 30 is 210 degrees. And theta 2 doesn't go a full 360, it goes 30 degrees less than that. So 360 minus 30 is 330 degrees. So these are the two answers to the equation. Sine of both of those angles equals -1/2, which means it makes cosecant -2, which would then make this left side of the equation be -2 plus 2, which is equal to 0. So both of these angles satisfy the original equation. They are both answers. There you go. Hopefully you now understand how to work with reciprocal trig functions.
हेलो बच्चों, तो आज इलेक्ट्रिक